Angela, I found that very spooky. Shall we carry on? All right. All right. Okay, that's not even true. Now it is making sense. There's so much real stuff to choose, and you just go there.
You birthed a student was true, but that wasn't.
What did I say?
I said, remember someone that almost birthed a student. Oh, what? It's like the opposite of killing a student. So it's like even now. No, he had somebody.
Like the EMT. All they do is they
Like the where they oh, I thought you birthed.
like a baby. You don't
All right.
you deliver it. You're not the one birthing it. You deliver it.
What a nice way to start the lesson.
As
Deliver the baby.
yeah, no, guys. First of all, my wife is a midwife, and she has a button that says, "Pizzas are delivered, babies are caught." That's what a midwife does. They catch a baby. And as for the person doing the birthing, that would be the mother. And I can confidently say, I have never birthed anybody.
Relatable.
Pretty sure. Looking back through if that's a memory I have, I've definitely repressed it. But anyway. But having said that, let's move on, shall we?
Yeah.
So, transforming periodic functions, and you'll note that I've given us a happy little snake here. What could you kind of model his shape with? If you imagine looking at that from above.
Oh my god, a snake looks like a snake.
Sine wave. No, we'll get to tan. Tan behaves interestingly. Tan's a little bit more funky. Tan's got a bit of funk going on. We'll get there, but not today. I don't think today. Okay.
I'm naming him sine wave.
So now listen. What I want to do is just quickly remind ourselves, what kind of transformations can we do? What kind of transformations can we do? And of course, we can stretch or compress. What kind of operation stretches and what kind of operation compresses?
The one where where a number is bigger than 1, that
Yep.
stretches.
Very good. So whatever we do with it, if the number is bigger than 1, it's going to stretch it. And that's because we are doing what? Multiplying. And of course, multiplying will stretch. And if we want to compress, dividing. And we can do this vertically or we can do it horizontally. First here, we're going to focus on doing so vertically, which means that we're affecting it in the up and down direction, right?
Yeah.
In other words, we're affecting the x's or the y's.
The y's.
Yeah, we're affecting the input or the output.
The
output. Which means that we need to do our multiplying or our dividing after we have done the function. And in this case, the function that makes this periodic is we take x and we do what to it? We take the sine. So if this function here is a sine wave, and how do we know that this is a sine wave? What's it start at?
Because I have eyes.
It starts at 0. Cosine starts at what?
1.
1. And what's its period?
360.
It takes 360 degrees to do a full rotation, right? So now, what is its amplitude? 1, right? Does that make sense? And what is its axis of symmetry? Or its central axis? Y equals 0. Do we see that?
Yeah.
So, a sine wave centers on 0. It has a period of 360, and it goes up by 1 and down by 1 over that period, right? Comfortable with that? The only thing we're going to change here, so that is the function that's already on the page. So now we're going to make a second one, g of x, and g of x is going to be the same function, but it's going to be multiplied by 2. What is that going to change? Yeah, it's going to change the height. And what term do we use for height? So this will have an amplitude of?
Hold on, I can guess. Amplitude of 2.
2. Good. And so if you look down here, the original function, we said that it started at 0. By 90, the sine wave moves up to what? The original sine wave, 1. By 180, it's moved back to 0. Then it goes to -1. Then it goes back to 0. Okay, in g at x, where we're doing 2 times sine x, have we changed the x values at all?
Nope.
Nope, so they'll still be
0,
90, 180, 270, and 360. But what have we done to all the y values now?
We've doubled them.
Double them. So this will be 2. It'll be 0. That's right. And then this will be
2.
2, then
0.
then
Negative 7,000.
negative 2, and
3.
0. Okay, don't be funny. Again, just because it's easy doesn't mean it's easy to everyone. And I used yellow for this, yeah? So there we go. So still at 0, but then it's going to go up all the way to 2. Then it's going to come back down to 0. And it's going to go as low as negative 2, back to 0, as high as positive 2, back to 0, as low as negative 2, back to 0, as high as positive 2, etc., etc. And then I can try to graph this nicely. Oh, this will go to negative 2. That'll go to positive 2. Oh, gosh.
I got this, guys.
I'm not going to say that's good, but that's better than I do sometimes. I think that's solidly okay. Does somebody want to turn these front lights off? I feel like I chose a light color there.
It looks god awful.
There's switches everywhere. I don't want to do the wrong one and like everything.
Front, please. That's a little better. On the other hand, what about a half of x? Half sine x. So again, if we are doing this outside of the sine function, then we're not changing the x's, we're changing the y's. So the x's should still be 0, 90, 180, 270, 360. But now 0 is still 0, but 1 will become
0.5.
Yep, a half or 0.5, 0, and then
Negative a half.
negative a half, then 0, etc. And so in this case, it should look like that. And obviously we're still on 0 in each case.
I've tried you. I'm gonna do a dotted line so at least a bit of a difference. There we go. It actually doesn't look that bad.
Now,
That's the new strategy. Make dotted lines because it looks better, and then just draw it in your dotted line.
so where we have f of x equals a times sine of x, the a just determines the,
So the vertical stretch or compressor.
yep, but in terms of the graph, the a is just the amplitude. Amplitude.
A for amplitude.
Yeah, that's actually pretty easy. Does that make sense? It just tells you how big this thing's going to go up and down by. And remember, that's how much it goes up and how much it goes down. So it doesn't tell you the whole range. In fact, the range will always be twice the amplitude. Does that make sense? Because it goes up by that much and down by that much. So if the amplitude is 2, the thing has a total range of 4. Right? If the amplitude is 8, it would have a total range of 16. Does that make sense? Cool. Because again, it goes up by that much and down by that much, and it goes up above and down below the what? What do we call the line that it's going? The axis of symmetry. Which by default is what? Which by default is y equals 0, right? Okay, good. Now, what if we did a vertical translation? What's a translation?
Just moving it. Just like kind of like shifting it. You like this.
Yeah, very good.
There you go. I gave a little visual.
So I'm just going to kind of pre-fill these out because, again, we know that we're dealing with vertical here. And if we say vertically, we are affecting the x's or the y's?
The Z's.
X's or the y's?
The y's.
The y's. Good. So you'll see I left the x's alone, right? Still 0, 90, 180, 270, 360 in my table. All right, so we have the original sine function here. And in the next one we want to do, we want to have it go up by how much? Up by 1. So we could do this visually if we wanted to, because we could say that this 0 is now going to be up at 1, and this 1 is now going to be up at 2, and this 0 is going to be up at, and this negative 1 will now live at, and this 0 will live up at, and 1 will live up at 2, 0 up at 1, negative 1 up at 0, 0 up at 1, 1 up at 2. Does that make sense? And we can just visually track that like this, and then we can do our best to draw. Where's the new axis going to be on this? Where's the new midpoint?
At 1.
The midpoint lives at 1 now. Can we kind of see that? I'm going to do my best to draw this smoothly. I will probably fail.
Don't worry, you're not the only one.
Oh, I've failed. Oh, golly, have I failed.
Hold on, I need to see this after I'm done.
You know what? We're going to call that good enough for rock and roll. It's a sine curve. Sorry, you think you can do better? Is that what you think? Huh?
What's the order? Oh, no.
Okay, well then maybe people in glass houses should shut up.
Yeah, I'm looking at it. So
That's the expression, right? People in glass houses should shut up. Do I have that right? Okay. But of course, we could have done that from table of values, right? What would happen to the point 0? It would become 1. The point 1 would become 2. The point 0 would become 1. Point 1 would become 2. Oh, yes, it is, which means it should become what?
0.
0. Thank you. Because the new y value is the original y value plus 1, right?
It's Cal for...
What are we learning?
Transformations of trig functions, which as it turns out are just like transformations of any other function.
It's the same thing all the time.
It's like the same thing all the time.
What if you used a different letter besides D or C or A or H?
The whole thing would break. The whole thing would break. Yeah,
What
you'd
if
be
I
done
use
for.
animals? What if I
G at
or
cat
emoticons for
is equal to the
I like
sign of
that.
cat.
They should use emojis.
yeah.
Could you imagine if from day one you'd learned like y equals eggplant x plus poop emoji? You know what I mean? Like that would be easier to remember. It's like, now we need to solve for poop emoji. Like, all right. Isolate the poop emoji.
Imagine doing a quadratic formula with emojis. Like, it wouldn't be easier to remember.
I don't know, it might be. It might be. Okay, I want you guys to do h of x equals sine x minus 5. Or 0.5 rather.
Okay.
And when you feel like you've got it, you can come put it up here if you like. But you take care of h of x equals sine x minus 5. How often do you say like f at x and how often do you say f of x?
Yeah,
I kind of go between the two.
I do. I'm very
I do at more than of, but I do both.
yeah. It's kind of weird. It's like the angle of elevation of versus 2. It's not weird saying angle of elevation of.
Yeah, that's true. Yeah,
Give us the answers.
But
Inclination. I've seen.
Oh.
Or how many grade 10 worksheets I've seen use the word function. Jordan's around somewhere else.
Guys, I think I cooked.
Looking forward to either feeling smug when somebody else struggles to draw a sine wave on the tablet, or completely defeated when they do a wonderful job.
yeah.
You think I'm mostly gonna? You think I'm looking at feeling bad? Is that what you think? You think you're right?
Hey, listen.
nice thing about being a dummy. Nobody expects
My
anything.
sandwich has.
Why do you got dirt by your foot?
This guy, if I show up with 2 socks on, I've succeeded.
Yes.
Get to work. Pretty good. Pretty good. Yeah, that was good. Well done. Probably a sumo.
Well, you forgot to fill out the table 0 to 10. Can't believe you've done this.
Shame on you.
She did.
Oh, you did?
Okay, but let's put the function on the table. Can I join you, Sam? Thank you. This was sine x plus or minus 0.5, correct? And so we said our new y value was just the old y value minus 0.5, right? Cool. Does that feel pretty logical?
Yeah.
And of course, this would make sense because, for example, if we were modeling how full the moon is never negative sunlight, right? It oscillates between 100% and 0, right? So right there, just if you think about it, if we wanted to do true transformations so that it went between 0 and 100, what would we have to do? Because in the end, if we have y equals a sine x, and they usually use a k at the end here. I don't know why, and I don't care. I could not care less what letter you use. But we said that a would tell us the amplitude, right? Which is how much above and below the axis.
Why are you all the way back there now?
And then we said that this value here, what does k really tell you? If you look here, really the easiest thing to think about, is what this centers on, what the axis of symmetry is. So we can think of k as telling us what the axis of symmetry is. That's a k. You can tell because it looks nothing like a k. Is that better? See, that looks like an uppercase k to me, though. I struggle to make a lowercase k.
Just make it an uppercase.
How's that?
Make this stick a little longer.
There we go. All right. Thank you for your insight. Now I feel like I really got it. So if we wanted this to go between 0 and 100, what would my equation have to be?
Oh wait.
Like X's or Y?
If I want it to go like, and that is at 100, and that is at 0. Okay, why 50? You're right.
Because what the middle part, the axis of symmetry to be at half of where you want the top part to be.
Very good. So between 0 and 100, the half point, right? The halfway point is 50. And the definition of the halfway point is the axis, the middle, right? So that's good. I like that. What else would I have to do? What would the amplitude have to be? Careful. Very good. Does that make sense? The amplitude would actually also have to be 50, right? Because this would go up by 50 and it would go down by 50 from a midpoint of 50. Does that make sense? So that's actually kind of a tricky one. But do you see how now we can start to design a function to model whatever we want? Cool. Now, what's the problem? Is that this would only work if we wanted to model something that took how long? 360. What if I don't want to take 360? What am I going to have to change? Not the y's, but the x's. So, shall we do that next? So the next thing we can do is we can horizontally stretch or compress. All right? And in this case, we need to multiply or divide the x values. But this should remind us of something. What do we know about our x's? So we'd say recall yeah. Which is actually to say just that we work in reverse operations with them. But regardless, so if this is our original sine wave here, where we could say this goes between 0, 1, 0, -1, and back to 0. If we do g of x equals sine 2x, we would expect, just by looking at it, that all the x values are being multiplied by, but in fact, they're not being multiplied by 2. In fact, they are being, yeah, and how do we shrink them? Dividing by 2. Dividing by 2. So this is g of x equals sine, and I will always make a habit of just putting this in brackets, because I like to know exactly what we're taking the sine of. So this is the sine of 2x, which means the y values, do they change at all? No. They're just the original y values. But the x values, you might think that we're multiplying them by 2, but in fact we are dividing them by 2. Does that make sense? So now this x value is 0. It will stay 0. But this x value had been 90. Now it will be 90 over 2, which is, excuse me, 45 degrees. But the y value doesn't change, so the y value will still be 1. And then 180, well, now it will be 90. Good. But its y value will still be 0. And then 270, well, that's going to be cut in half to 135. But its y value will still be -1. And then finally, the x value is 180, and its y value will still be 0. So what's this going to look like on the graph?
It's just going to look like it's squished.
Yeah, right? So this, what color was I using for this one? Green? Yeah. So this x value still lives there, but this x value is going to get cut in half, right? And then this x value is going to get cut in half, right? So 180 is now going to be at 90. And then 270, well, what's it going to be at now? 135, which will be right there. And then 360, there it is. And then 360 is going to live at 180. And then 450 is going to live at 225, right? And then 540 is going to live at 270. And what we see is that it follows the same pattern, but it does so compressed, right? Everything cut in half.
How am I supposed to visualize this?
If you think it would help, Sam.
Okay. Well, that was good.
I completely missed one of the dots. Wow. Right. Good enough.
Yeah, listen, and just do your best. Oh, golly.
Let's concentrate. Let him cook.
Let them cook.
So wait, does that mean instead of dividing you multiply?
That's right.
Then I can do the next one. So that'd be 0, 1, 2. What's 270 times 2?
Okay, so I'd like you guys to try, if you can, to do sine 1/2 x yourself. Perhaps you already are. If you're not, give it a try. Whoa. Yarsh.
You didn't even let me finish my
Yarsh.
statement.
Wow.
I was attacking you or not? Because for the record, I was not attacking. I was
And for the
literally
record, I
gonna
did
say,
not ask for your opinion.
okay.
Okay, guys. We're friends. We're a team.
That's so
You guys are a volleyball team. You're a math team. We're in this together. It's not us against each other. It's us versus like Kelford's class.
And yet when we
And I plan by the end of the year to physically attack them. And I need you to all be on the same team as we conquer Kelford's class.
the difference is in volleyball.
I want to turn Calford's room into like our little storage room where we just keep stuff. And maybe like as a nice little quiet place if we need it. No, if he knew of our plans, he'd be able to prepare and defend. I want him to be shocked when we show up, ready for battle.
You know why that's not accurate? Because in volleyball, if one person messes up, it's all lose. But here, if she passes and I fail, she's winning one.
Well, this is what you don't know, guys. I've decided to give you all the grade of the lowest grade in this class.
What?
Yeah, true story.
Are you serious?
Sure, why not? That's how volleyball works, right?
Just give us 2 minutes.
You don't get different scores.
I'm gonna cry.
For the record, I think it'd be pretty great. Whoa! Wow!
Okay, can I be honest?
Wow!
Can I be honest?
Yo, that was
So honest.
deadly.
Can I be so honest?
That was
Because
so
literally-
unkind.
You literally just said what I was thinking.
That was so unkind.
What I was thinking.
Annie Novak, I'm disgusted. I am. No, I'm shocked. There's a difference. What are you doing?
I'm doing that.
Are you?
Yeah.
Would you face it towards yourself then?
I like doing stuff up there. There's a dot there. There's one there.
Okay, shh, guys, look at me. That green function, what was its period? Y equals 2x, y equals sine 2x. What is its period? How long does it take to do one full cycle? How much? 180. What's the period of a default sine wave? 360. So if we compress it by 2, right, what happens to the function? Its period gets divided by 2. We could dial the period we want in, right? If we wanted this thing to repeat every 36 days, we could just make it 10 times smaller, right? What about when we divided it by 2, the one that Sam is working on right now? And obviously this gets messy, but what's the period become now? 720, right? Can we all see that?
Yeah.
It's a little messy here, but in this blue one, to go from 0 to 1, back to 0 to -1 and to 0, now, if it's sine of 1/2 x, you would think that we're dividing x's by 2, but what are we actually doing? We're actually taking the original values and doing what? X's lie. So if it says divide by 2, what are we actually doing? Multiplying by 2. So the 0 becomes 0, but 90 times 2 is actually 180. And then 180 times 2 is actually 360. And 270 times 2 is actually 540. And 360 times 2 is actually 720. And so now a full period takes 720. So let's note that. The period of the default function is 360. When we did sine 2x, the period became 180. We divided it by 2. And then when it was sine x over 2 or sine 1/2 x, the period, I don't know why I put that in brackets. The period was 720, right? So the period, so if we have y equals whatever we want, a, and then in here we have b times sine of x plus k. We said that the A sets the what again? The amplitude. We said that this k at the end is going to do what? It's going to move it up or down, which sets the axis of symmetry. But then this one is a little bit weird in that this b value sets the period, but the period of a sine wave is always going to be 360 divided by whatever this b value is. Does that make sense? Because 360 is the default period of a sine wave. Does that make sense? What would we put in for b if we wanted the period to just be 1? 360. Does that make sense? So, this is actually a good thing to know. You can make a little box here. To set the period to some value, you can say b equals 360 over the desired value. Does that make sense? If you want a period of 11, no problem. Just make b 360 over 11. Does that make sense? The 360 will divide it out to 1, and then dividing by 11 will actually multiply it by 11 and set it to 11. Does that make sense? If you did 360 over 28, that would set your period at 28 days. If you did 360 over 19.257, now your period would be 19.257. So do you start to see how you can just dial in a function however you want? Cool. Now, the last thing is, what has every one of our functions started at so far? 0. Does it always make sense to start at 0? Sometimes we don't start in the middle. Sometimes we start at the top or the bottom. Does that make sense? So, the last thing we can look at is what if we want to translate it. This is sometimes also called, in physics, this would be called a phase shift. A phase shift. Now again, when we're adding, we have to remember that what do our x's do to us? They lie. So we go back to the original function, and we say that in a standard sine wave, 0 is at 0, 90 degrees gives us a sine of 1, 180 gives us a sine of 0, 270 gives us a sine of negative 1, and 360 gives us a sine of 0 again. That's the standard sine wave, right? For g at x, we want to do sine g of x is equal to sine of x plus 180. Can you confirm that for me? That's actually what I wrote. Are we changing the y values at all? No, so they're going to stay the same, right? There's nothing outside the sine. It sounds like the sound effect they'd use for like a windy Christmas day. Like that's what that sounded like. Like if you're watching like a radio play and they had to do like Foley sound. Anyway. Okay, but the x's, it says here to add 180. Well, what do we know about x's? They lie to us. So the new x values are actually the old x values minus 180, which means that this one here would not be 0. It would be negative 180. The next one would be negative 90, then 0, then 90 is correct, and 180. Now, what you'll notice then is that this 0 still is at 0, isn't it? Okay, but this positive 90 now lives at negative 90, right? And then this 180 now lives at 0. And this now lives there, right? And from there, you can kind of just keep going. And you see, what has happened with the particular value I chose to shift by? How does this graph compare to the previous one?
It's the same thing, but you went to the left by 180.
And you start at the thing kind of starts at -1 and ends at 10.
Yeah, very good. Is there another way we could have gotten this effect? Is there something we could have multiplied by that would have done this same thing? Yeah. Could we have done, just hypothetically, could we have taken that sine x curve and just flipped all the y values like that? Yeah. So that would actually also work to give this same effect. But we did it here by sliding the whole thing to the left by how much? Left by 180. Does that make sense? What are we going to do with h of x? We're going to slide this to the, yeah, and I should say shift or translate. So try that one. Everyone make h of x shifted to the right by 90. Sorry? You're like the Jackson Pollock of mathematics. So you couldn't hear what? Okay, first of all, when we say that artist, which artist got off his ear?
Van Gogh.
Yeah, that's Van Gogh. Very good.
Sorry.
Yeah, no, you're fine. That's good. His name's Van Gogh. I have a collection, a really beautiful book at home, but it's a publication of all of his. He was a prolific writer of letters, and he wrote letters to his brother Theo Van Gogh, and these were published later after his death. It's an interesting thing where, like, with famous people, back in the day, of course, for you these things are all digital, but people used to write letters, right? Like, write letters and send them in the mail, which you should all do. You know, there's nothing nicer than getting a letter in the mail. There's something very special feeling about it. But anyway, but could you imagine, I always think this is so invasive. So, like, Vincent van Gogh died, he killed himself, right? And then, like, after his death, like, all of his private letters, like, between he and his brother and between he and his I don't know if they were married, but his, like, love interest, they're all published and you can read them. And I think about this, like, same with, like, Abraham Lincoln. Like, I went through a phase where I read, like, everything Lincoln had ever written. But you get all these very private personal letters, and I think, like, boy, when I die, I mean, first of all, luckily no one will care. But second of all, if somebody did care to read all my, like, correspondence, I'd be like, boy, I really would not like that. You know? But one of the crazy things is, like, how well people wrote. Like, I have a book of Civil War letters, like, just letters that people wrote during the Civil War to their families. And you realize, like, the level at which the average person was writing then, very, very, very impressive. Like, very sort of... We think of America as being like a backwards kind of hick town, but at the time, what America was most famous for was having the most educated population on Earth by far. America had by far the most robust public education system of any country on Earth. So, like, by the time of the American Civil War, the average American citizen was more well-educated than any other place on Earth, where education was largely something that people paid for. But by and large, throughout America, at least for, like, the white landowning sort of average civilization, very well-educated. Not the reputation we think of them as having today, but we should. I mean, they're still a very well-educated country, but well, they are. I mean, just on the face of it. But it is weird. It's interesting to note that your generation in, like, North America is the first generation in 200 years where literacy rates have declined. Isn't that kind of a scary thought to think? Like, it's the first time in you know, since, like, the dawn of public education that, like, the rate at which we are literate is declining. I mean, it makes sense, right? Because when you have technology that can do it for you, it's easy to slip through the cracks. The pandemic definitely did not help, but this was a trend before the pandemic. But no, the pandemic definitely did. Let me tell you, anything related to education, you know what did not help? Pandemic. And you guys I wonder who had it the worst.
Probably people like
I-
Just starting out in high school when it started.
She missed like primary like stuff.
Yeah.
Those are like the core grades. People learn to like count and
Yeah. I think probably the worst of the worst would have been to people in like SK1, 2, and like that kind of range there. And then I felt bad for everyone who like basically their whole high school career was pandemic. That sucked. But maybe, I don't know, people who went to university, it sucked for everyone. I think that's what we can take away. Most fascinating. Some people I think really like enjoyed it. Like you've got your introverts who are just like, it was kind of great. Boy, I don't relate to that.
My school in grade 7, it was every other. You go to school every other day.
It's awful. I mean, probably. Oh, and you missed it. And you missed both of them. That sucks.
You're supposed to go to Tim Hortons camp for a 3-day or a 3-night stay.
I don't know. I didn't go on my grade 8 graduation. I should have, but I didn't.
Where was it?
I have no idea. I went to school in Scarborough.
Fair enough.
So
All right. Okay, let's take a look. So what do we get for this? Again, do the y values change? No. So this would be 0, 1, 0, -1, and 0. Okay. But the x values now would be what? It'd be 0 plus 90, which is obviously just 90. That'd be 90 plus 90, which is 180. Then 180 plus 90, which is 270. And 360. And then how much? 450. Good. And functionally, what that means is you can take the original red function and everything should shift. What color did I use here? Yellow? Everything should shift to the right by how much? Right by 90, right? So that goes there, right? And then this goes here. That goes there. This goes here. That goes there. This goes here. That goes there. That goes there. Yeah. Yep, absolutely. You are very welcome. Oh, this already sucks. I'm so sad. Sorry? No. Do you feel like we're rushing?
It's because Mr. Linda's on a roll. Literally, you spent 5 minutes on a one note yesterday. It's beautiful.
Okay, guys, we don't need to criticize. We don't need to criticize. Do you know, boy, like, I totally changed how I taught. When I taught at South Lincoln, I had a bunch of, like, focused farm kids who were always, like, on point. And there, my lessons were consistently, like, 30 to max 40 minutes, and then, like, work period. And that was because I only had 60-minute periods to work with. And then when I came here, I used to finish that early, and I'd be like, all right, work period. And I had some wild classes here at the beginning, and like it'd be like work period, and then the class would like erupt into chaos, and there'd be like just noise and shouting and nothing productive happening. And I learned that I hate that a lot. So I developed my new habit of trying to stretch my lessons to fit the period precisely from bell to bell, which may seem random sometimes, but it actually is pointed that I hate dead air, and I hate like wasted time. So you guys are... Well, I don't know if you're okay. You're about a 4 out of 10 on using time. If you got yourselves up above 5 to like 6 or 7, you might get some shorter lessons. But you don't always make the best use of your free time. I hope you'd agree. Okay, so now here, I want to go back to imagining the moon. That sounds very esoteric. Can we all just imagine the moon? Everyone shut your eyes.
Oh, it's nighttime. I gotta go to bed.
Okay. Here's what I want to imagine. I want to imagine that the moon, in 28 days, goes from a new moon. Oh, okay, stop, thank you. From new moon to new moon. What is a new moon, quote unquote? Well, it really means that the moon is lit up, but the part of the moon that's lit up is facing away from us. So what we would see then on day 0 is we would see a moon that is entirely black, right? And actually that's during the daytime, so you wouldn't see it anyways. And on day 28, we'd be back to a moon that is entirely black. New moon to new moon. On day 14, what would we have? Not half a moon. What would we have? We'd have the full moon, right? Okay.
Mr. Orlando,
Yeah.
why don't you just take the solar eclipse when you're calculating?
Well, we'll get there. What would we have on day 7 and on day 21?
Half.
Yeah. And we would have what we call the waxing half moon and the waning half moon.
You just call it half moon.
I'll call it what I like. And in fact, they're called the quarter moons because we call it, you might sort of feel inclined to call it a half moon, but really it's so-called, this is the third quarter moon because it's the third quarter of the cycle, and this is called the first quarter moon.
That makes sense.
And does anyone know what we get before then?
Like a kind of half of the half.
We get what we call the crescent moon and the gibbous moon. And again, we have the waxing crescent, waxing gibbous, and then we also have the waning gibbous moon and the waning crescent moon. Right? Can you picture that? Yeah. Okay. If we look at these as percentages, this would be 0% full, right? And then on day 7, we'd be at 50% sunlight or moonlight. On day 14, we'd be at 100% moonlight. On day 21, we'd be at 50% moonlight. And on day 28, we'd be back down to 0. Okay, so let's talk about modeling this. What do we need the period to be? We need the period to be 28 days. What do we need the median value to be? In other words, the axis of symmetry.
That'd be 50.
50. Good. And then, what do we need the amplitude to be?
100.
Yeah, because it goes up by 50 and then it goes down by 50 from an original value of 50. And then the nice thing is, where do we have this starting at least? This needs to start at 0, and specifically it starts at 0, and from there it's going up. Now the nice thing is, this is standard for a sine curve, right? Sine starts at 0 and it goes up. So what we don't need is a phase shift, which is nice. But otherwise, we have to change everything about this. So we could say y equals sine of x, right? But normally, with no number here, what's the amplitude? 1. What do we need the amplitude to be? So where do we put that? Yeah, putting 50 out in front, will that will make the amplitude 50, right? Does that make sense? Because it multiplies it. It'll make the one that it used to go up to will go up to 50, and the negative one it used to go to will now go to negative 50. Does that make sense? But of course, I don't want it to go between positive 50 and negative 50. I want it to go between
0 and 100.
Great. So how do I do that?
You have to change the x
To what?
to 50, so it can go to
Great. And where does that go?
behind the x.
Very good. At the end, right? Like that. And then how do I set the period to 28 days? This is the tricky one. What is the period by default?
360.
So I need to divide this by 360. But of course, x's lie to us. So if I need to divide it by 360, do I actually divide it by 360? I actually put it in here as multiplication. And then what do I want the period to be? 28. So you'd think I'd want to multiply it by 28, which means really I need to divide it by 28. And that should be a function that models the sunlight of the moon. Does that make sense? And so now what we could do is we should be able to go to Desmos. Oh, that's OneNote, not Desmos. And here we are. And we'd say y equals, what was our equation there? 50 sine 50. And I'm just going to do sine x for the moment. 50 sine x plus 50, right? Oh, and I need to put this into degrees mode. Very important. If you set it to not degrees mode, it won't behave nicely. And what do we notice? Right now it'll start in the middle, right? Go there. Now we don't actually want it to cycle from, we don't want it to take 360 days. We want it to take how long? So we divide it by 360 by multiplying, right? And now it'll happen every single day. What the indeed? Right? We see now it's cycling every 1 day. But then we want to make that actually cycle every 28 days, right? So like that. Now the only problem is this didn't actually start us at 0. It started us at 50. So I need to shift this to the right. By how much? Yeah, if you look here, how many days? 7 days. Does that make sense? A quarter cycle. How would I shift this by that much? Well, I'd have to put brackets around my x, right? And you'd think that I'd want to do plus 7, but of course our x's lie to us, so actually we want to do minus 7. And now it starts at the bottom. Does that make sense? We had to shift it by a quarter cycle. Does that make sense? We're going to be doing a lot of this, but if you want to design a sine function to do something for you, you can just design it to do it for you. Like, you can just do that. Later on, we're going to do an activity where we make a musical instrument. We're going to make our own synthesizer. I'm going to give you a sine wave of like a guitar and say, I want you to try and use Desmos to match that sine wave using functions here. And then we're going to actually plug it into some software and actually play the sound you made and see if you've made a synthesizer that sounds like a guitar. And usually what people come up with is the sounds sound like cheesy synthesizers from the 80s. Because in the 80s, do you know how they made a guitar sound for a synthesizer? Just like this, just how we're doing it here. They actually used physical oscillators. But we can design something to do what we want it to do. Does that make sense? By the way, if you're wondering what I mean when I say a sound file, I was helping my niece record a song yesterday for... No. I have no rhythm. I play guitar, like I record, but I have no sense of rhythm. And I largely hate the sound of, my favorite thing in the world is like listening to a live band with a live drummer that like breathes and speeds up and slows down. And part of what I find just unlistenable about modern music is that it is all just snapped onto a grid and the tempo is just locked in and it has no life whatsoever. And when I hear it, it makes me like, I find it so painful to listen to because it's just completely lifeless. So yeah, all of which is to say no. But it's okay. So here we go. Like, there should be a guitar sound on here somewhere. We can actually look in. Like, you can actually see that if you take a sound wave and zoom in on it enough, can I get rid of the mixer here? Yeah, there we go. Okay, so here's like a guitar sound. And if we zoom in close enough, you can see that what is it? Now, this is stereo, right? Because there's a left and a right. So maybe this piano signal isn't left and right, so we can go with that. But if you look, it's just waves, right? Yep. Sorry?
We're almost 700. You could have been special.
I'm special. My mother says so. Actually, she doesn't. That's not even true.
Mother also says so, but I think she means different types of special.
Yeah, see, my mother used to always say it takes a village to raise an idiot. Which I guess is hurtful. But, oh!
Mr. Orlando, does this not remind you of Sam?
Oh, kind of. Yeah.